Welcome to our video module on HVAC basics. First, what do we mean by HVAC? We mean heating, ventilation, and air conditioning, the basic functions of conditioning a space. Now, when this system is working well, you never notice it, but we've all felt what the system feels like when it's not working well. For instance, maybe you're the first class in a classroom where the air conditioning has been accidentally left on all night and it's really cold. But it's not just too cool or too warm, it's also the type of overall conditioning you experience. For instance, in my house for a while, we kept the house warm in the wintertime through a fireplace, which was great if you were facing the fireplace. Your front would get all warm and it was all cozy. But when the fire was really raging, your face and your front would get all warm and then your back would be cold. I'm sure many of you have felt this effect when you're gathered around a campfire in the fall. These types of challenges are what we need to overcome in our HVAC system design. How do we control the environment effectively? This is the core question we're going to address today as we look at temperature, airflow, and humidity, as well as some of the other variables that affect environmental control in real projects. Now, before we get any further, one of the primary ways that we talk about how warm or cool something is through temperature. And it's important to note that as humans, we do not sense temperature. Rather, we sense heat transfer. This is why clear nights feel so much cooler than cloudy nights, even when the temperature is exactly the same. It's because on the clear nights, we're radiating to outer space, whereas on the cool nights, we're radiating to clouds, which are a much warmer temperature. It's also why you can stand in 60-degree weather with the sun beating down on your face and it feels really enjoyable, relaxing, and comfortable. Whereas if you jump in the cold tank at Bozeman Hot Springs, which is also at 60 degrees, you have a completely different experience. That said, the three topics we'll be talking about today are temperature, airflow, and humidity. First, temperature. While we as humans experience heat transfer, that's what we sense. Temperature is a big aspect of that. Guidelines that we have are that in an office space, we're looking at a temperature of somewhere of 70 to 75. If you're doing hard work, let's say you're have some challenging labor in a manufacturing area, we might go as low as 65. But generally, anytime we have temperature on skin in a controlled environment, this is about as low as we like to go for comfort purposes. Now, cooling a space where airflow on open skin isn't a problem, we might go below 65. And in fact, if we go to, say, something like food processing centers, we might go somewhere around 40 degrees, or say I toured the Ben & Jerry factory once and they were running it at well below this. So these are basic guidelines for the temperature of the space. The second important idea I'd like to cover today is airflow. Now I've included here a sketch of a basic clean room that one might experience. We have a workspace here and some shelves. And what we're interested in is how we're cooling the space. So you can imagine along the ceiling, there's some supply air. And let's say we put some return air ductwork along the wall, say right here. Speaking of supply and return air, you'll notice in this diagram that I've used SA to indicate supply air and RA to indicate return air. Now the best way to look at this is from an elevation view. So let's move this up and sketch out some of the airflow. Now what we have here are the supply air, which are the X's with the side dashes, supplying the air to the space. And in this case, if let's say we look from this perspective, that is this elevation, it means that the cool air is coming down here from the fan filter units or the supply air filter units here. And the way I've drawn the ceiling plan, it means that the return air, and we'll put that in red, the return air units are over here, and that is the airflow going here. It's important to note that anytime you're conditioning a space, you're going to have the supply air right here, and in addition, there's return air right here. So what happens is the air flows through the space, it heats up, basically because it encounters warm people or it encounters machinery or all the things that are warming up the space, and then it returns. Well, where does it return to? We're going to put up here, let's say on the roof, is something we call an air handling unit, or AHU. And air handling units use ductwork. So you can imagine the airflow coming out here and going down through this ductwork. You could probably look up if you're in an industrial building and you can see ductwork in the ceiling, maybe in the norm, to supply the cool air that people feel. But that's only half the equation. In addition, the return air that comes out of that space goes back up to the air handling unit, also through ducts. And it's within this air handling unit that the air is cooled down, or it's conditioned, or we add humidity, or we take away humidity, or maybe we purify air. Generally, somewhere in here, you'll have something that looks like this, which is a fan. So that both blows air out, and I'm not going to say it sucks the air in, but it helps the return air move through the system. One option that's sometimes used is two fans, one for supply air, one for return, for a number of reasons, one of which is to reduce noise in the space. However, it is also more expensive. The second feature that's often used in an air handling unit, I'll try and draw it here. Yeah, let's zoom in a little bit on this air handling unit. And another feature that we might add to the air handling unit is, say, a filter that might go here. And generally for clean rooms, this fan filter unit is adequate at levels of class 1000 or dirtier. But once we move to class 100, we need both the filtering at location as well as a pre-filter in the air handling unit. One further note is while my ceiling plan shows a return air in the ceiling, on my sketch I also threw out the possibility of maybe putting return air grills down here, and then the ductwork, they would have to find some ductwork to get that return air back to the air handling unit. Let's return to the top and talk briefly about humidity. This is the amount of moisture that's in the air. Generally in an office setting, we have a pretty broad latitude of 20 to 60% in an office. However, if we're running in the pharmaceutical industry, we'll want a lower humidity, say something like 20%. This keeps water vapor out of the air, which can act as a host for bacteria. On the flip side, we might want to run, say, 40 to 50% humidity if we're working in the semiconductor industry. And besides process demands, this also impacts static electric fields and keeps their impact minimal. So one might ask, how do we do that? How do we humidify the air? It comes back to our air handling unit right here. One can imagine in front of the filter, there's some additional section of the air handling unit that adds humidity to the air when it's necessary. These are the only three aspects of conditioning the space that we're going to worry about for this project, but it's important to know that there's other aspects of conditioning that are really important. For instance, one thing we haven't talked about is what we say is load. How hard does the air handler have to work to keep this temperature of, say, 70, 75 degrees? One can imagine a space that's full of 20 people. The air handler has to work harder to keep that space cool. Or maybe it's running a CNC mill that's generating a lot of heat. Another aspect of conditioning space is variable demands on the system. For instance, during the daytime, the system demands are very different than during the evening time. Or you might have one air handling unit that is supplying both office space and areas where workers are exerting high physical effort. Another example is fresh air. So back in the day, a common problem was building sickness, where the air that was supplied within the office just kept recirculating and recirculating, and you end up with this carbon dioxide increase as well as other contaminants in the air. And speaking of contaminants, controlling a space may also have to filter out, let's say in an office space, things like pollen that can cause allergies. Here I should note that what we've covered here truly is the tip of the iceberg, that there are books and books of graphs and tables and theory to design a space effectively in actual applications. However, for this project, all we're looking at is temperature, airflow, and humidity. We've taken a chance to understand what the temperature ought to be, how the airflow works with an air handling unit, and what type of humidity we're trying to maintain in different scenarios. I hope this gives you a very basic understanding of HVAC systems in the cleanroom environment.